Hey there, and welcome to Point of Division. This is actually very similar to the midpoint, where we use this to find the coordinates of a point on a line segment. When we did the midpoint, the point that we found was right in the middle. It was halfway in between our points A and B. This time, instead of finding it right halfway, we're going to find it in different parts of the line. So say we have a line like A to B, we are going to be finding places instead of halfway, we're going to be finding places like 1/3 of the way. So you imagine that you break up this line into three pieces, and our new point, point P, lands 1/3 of the way. Now, the questions that we do will be represented, so this is 1/3 of AB, will be represented in two ways. It'll be represented as a fraction like this is 1/3, or it will be represented as a ratio. So point P is 1 to 2 from A to B. So 1/3 is also represented as 1 to 2. When we did midpoint and distance, it didn't matter where we started. But with point of division, it does matter which one is our point 1 and our point 2. Because if we talked about this same point P, but we looked at it from a starting point of B, this means that it's actually 2/3 of BA. And it is a fraction of a ratio of 2 to 1 on BA. Because if you start at B, your ratio has 2 to 1. So your starting point matters. What this means is x1, y1 and x2, y2 matter. They didn't matter when we did the midpoint because it was exactly halfway, and it didn't matter when we did the distance because it's the same distance. The formula that we're going to be using is as follows. It's this big formula right here. This gives us our x coordinate for the new point, and this half gives us our y coordinate of the new point. This fraction, AB, refers to the fraction above. So this fraction refers to this fraction. Basically, you're just applying a formula, very much like the distance and like the midpoint formulas. So let's just jump into an example. It says point P divides segment AB in a ratio of 3 to 1. So basically, we have a line. Oh, sorry, I forgot the blue marker doesn't work. We have a line from A to B, and it's broken up into 4 pieces. 3 plus 1 gives us 4, so there's 1, 2, 3, 4. Try and pretend that these are equal. Our point P is 3 to 1, so this is where point P lies. It's basically 3/4 of the way there. Our A coordinates are 4 and 6, and our B coordinates are -4 and -10. I mean, this is obviously not drawn on a Cartesian plane, and it's not drawn to scale. The reason I'm doing this is so that I can see that my fraction is actually 3/4. It's 3/4 of the way from A to B. This becomes important because when I want to plug it into the formula, I need to know what the fraction is. So if I want to find the coordinates of P, basically to find the x value of P, I'm going to use x1 plus A over B, x2 minus x1. When I substitute my values in, I get my starting point is A, so this is my x1, so I get 4, plus, this is 3/4. My x2 is my second coordinate, so that's -4. Oh, excuse me, there should not be a comma there. minus my first coordinate, which is a 4. As I continue, we just follow BEDMAS, so I need to get rid of these brackets. I still have 3 over 4. Negative 4 minus 4 is negative 8. Next, I can do the multiplication and the division. Negative 8 divided by 4 is negative 2. I'm still left with this 3 and this 4. Might remember this from our review of fractions. And then I have 4 plus negative 6, which is equal to negative 2. This is my x-coordinate for this point. I need to do the exact same thing with the y-coordinate. So my y for p is equal to y1 plus the fraction y2 minus y1. So I again just substitute in my values. So the first y-coordinate is 6 from here. My fraction I found was 3/4. And my y2 minus y1 is negative 10 minus my first y-coordinate, which is 6. So I end up with 6 plus 3 over 4. Negative 10 minus 6 is negative 16. Again, I can reduce the 16 and the 4. This leaves me with 6 plus 3 times negative 4. I'm just going to continue up here. Then I get 6 plus negative 12 is negative 6. This is my y-coordinate. So my new point P that lies 3/4 of the way is negative 2 and negative 6. Second example. Point P is situated 1/3 of the way between 2, 3 and point B, negative 1, 6. What are the coordinates of P? So again, it's exactly the same thing. I need to use this formula where point P is equal to, and we had x1 plus the fraction, the difference of the x's, and then the y-coordinate is just the same thing, but with y, so it's y1 plus a over b, and we have y2 minus y1. And this is the coordinates for point P. If I plug the values in from my question, I get that point P is equal to, and I use the first x value, which is 2, plus the fraction, which is 1/3, x2, negative 1, minus x1, which is 2. I got that from here and here. This is all for the x side. And for the y side, I have y1, which is 3, plus 1/3, difference in the y's, 6 minus 3. And this is my calculation for the y. I'm just going to find another color. So this is my calculation for the y-coordinate, and this is my calculation for the x-coordinate. You can do them separate, just as I did in the first example. You can also do them simultaneously, as I'm doing here. So as I continue, I follow BEDMAS, or the order of operations. I get negative 3 here. On this side, I get 3 plus 1/3, and this is 3. Reduce the fractions, so I get 2 plus 3 divided by 3 is, or sorry, negative 3 divided by 3 is negative 1. 3 plus, again, these reduce, so I'm left with 1. Here I have 2 plus negative 1, and I have 3 plus 1. Here I get 2 plus negative 1 is 1, and 3 plus 1 is 4. So point P has the coordinates of 1, 4.